Welcome to the kontinuumLAB. I'm Jeppe and this is Kontrol Freak. I make a new MIDI controller in every video. I make it up as I go along using scraps that I have lying around, and then I jam for a bit and record another voice for the Kontrol Freak theme song, which is what's playing right now. Welcome to yet another Kontrol Freak video. If you're new around here and you're wondering what the Kontrol Freak's all about, it's really pretty simple. I make MIDI controllers. The reason why they always end up kind of freaky is because I use some surprising materials. I'll use recycled cardboard, I'll use recycled wood, recycled plastic, I'll recycle components, I'll use cheap components, I'll upcycle cheap materials, I'll stick it all together with gaffer's tape and gum. No, actually I've never made a MIDI controller out of gum. Note to self, make a MIDI controller out of gum. Anyway, so today I'm going to make some cool finger percussion. So some little drums that you can play with your fingers using really cheap components and some recycled and upcycled materials. So let's get to it. So finger drums. As usual, I've put together some different supplies here in this little box that I think are going to be helpful in building these drums. And for once, the box itself is not part of the project, so buy a little box. Okay, so here we have 4 small pieces of bamboo. There's some strip board. There are some balloons. These are just normal kids' toy balloons. Then I have some of the foam sticky tape that I use for a lot of projects. This is super handy. I'm going to be needing it for this. Then I have a bunch of rubber bands, and then of course there are these guys here. So full disclosure, today I'm actually recycling the project itself as well as these components, and what that basically means is that I already built a set of these finger drums here a few months back before I started the Kontrol Freak video series, and I just liked the design so much that I decided now to just take them apart and reuse this part here to show you how I made them. But of course I want to show you how these boards are put together specifically. So I'm actually going to make one more using one of these CNY70 sensors, some strip board and a couple of resistors. But before we actually start soldering stuff together, I think it would be a really good idea to just take a closer look at the CNY70 sensor itself with its little LED photo sensor combo here on the front and its 4 pins here in the back. The first time I tried to use one of these, I was very confused by the material I found online, and so you can consider this my little tutorial on how to get started with the CNY70. The CNY70 is all kinds of awesome. It's super cheap, it's like 70 € a piece, and you can use it for a lot of really nice and interesting stuff. So the basic idea of how it works is that within this little square-ish box, you have on one side an LED, and that's constantly shining a light outwards. And then right next to that you have a little photo sensor here, and that's constantly measuring whether or not any light is coming back. And so if you have an obstruction in front of the sensor, then that light will be reflected back and be measured by this sensor here. And this is basically the way that I'm going to be using these sensors today, as a distance sensor, so that when the obstruction gets closer to the sensor or further away, we will have an analog signal change in the little photo sensor. Now we're going to look at the CNY70 from below, which means that we still have exactly the same square shape, but now we can see the 4 pins. So not being able to see the LED and the photo sensor makes it a little bit harder to navigate, so let's look at the sides of the sensor, and we will see that on this side here we have some text, and on this other side here we have a little dot. Great. So let's just split this down in the middle again and check which side is which. So the side with the text has the sensor on it, and the side with the dot has the LED. So we know that the LED side will have a positive and negative terminal, and that we need to connect one of those 2 sides through a resistor. And we also know that the side with the sensor on it has 1 pin that should go directly off to ground, and then on the other side it has a pin that should go to the analog pin on the teensy, and then have a resistor running off to the voltage signal as well. So I consulted the datasheet and was able to figure out that this pin here and this pin here are indeed the ground pins. So the first thing we will do when we connect the CNY70 and solder everything together is to just connect these two pins directly and then just draw a cable off straight to ground. So these two here are ground pins. Okay, so that means that by the process of elimination, this other pin here for the LED is going to go through a resistor and off to our 3-volt signal. And this other pin here is going to go straight to the analog pin on the TNC and then split off via a resistor that goes off to 3 volts. So remember, we're looking at the CNY70 from below here, so we can actually see the pins. And if you're handling the CNY70 and you feel a little bit lost as to which pin is which, then just have a good look here. There's the text and here's the dot, and that's going to define the position of all the pins. Okay, that's enough scribbling for today. Let's start putting this together. So I'm going to assume that it's kind of obvious how this all has to fit together. The pieces of bamboo here are going to be the basic structure of each drum. Then of course the balloons are here to make some kind of membrane on top of that. And the reason why there is 2 different colors of balloon I'll get back to in a second. Then we have the strip board here, which I'm going to cut roughly into the size of the interior diameter of the bamboo. And then of course I need to solder the components on there, which means the CNY70 and 2 resistors. So once all of the components are soldered into place, it becomes really hard, not to say impossible, to change the sensitivity on the photosensor here on the CNY70. And so instead of adjusting the sensitivity, I'm going to adjust the position of the sensor within the drum. So now this strip board will be cut down to the correct shape to fit in here, and then I'm going to cut out some thin strips of this foam flexible sticky tape here and run it along the inside of the length of the bamboo. 3 or 4 strips so that I can situate the piece in there and it'll be stuck in between those pieces, but I will still be able to move it up and down given the flexible nature of the tape. That's actually an improvement over the previous design, which is where I got these sensors from. As you can see here, these were actually glued into the drum with hot glue, and so there was no option to adjust the exact position after the fact. So that really just leaves the question of the 2 different colors of balloon. And let me explain that. So remember that we're dealing with a photosensor here. The light that shines from the LED here on the CNY70 needs as bright as possible of a surface to reflect from, so that the sensor can get as good of a reading as possible. And so I use the white balloon for that. The problem with the white balloon is that it's kind of translucent. Once you get into really bright conditions like sunlight or so, then that becomes a problem for the sensor, which gets a lot of false readings. And so that's why I have a second membrane that I'll put on top. This is a black balloon, very dense black, absolutely not translucent, and so that fixes that problem by simply adding another layer to the membrane. Right, so remember the drawing that I made before? Actually, let's just put that on screen for a second. So you see how those 2 ground pins connect together? So that's the first connection we're going to make, but before we do that, we need to prepare the strip board. So let's just grab our CNY70 and try to place it more or less in the middle. It doesn't really matter which way it's turning right now, we just want to find the middle of the strip board. And now on my board, the strips are running right to left. And so I want to score the whole board down the middle in this direction here. So that we can separate one section on one side from the other section on the other side. I'm just going to make a little mark there. Right there. Nice. So let's fit the CNY70 back in here. Okay, so from now on I'm going to orient this component just like it was in the drawing that I made before. Which means that I'm going to keep the text, which is on one side of the component here, against my body. So then I hold it like that and rotate it around this way. These 2 pins here are now the photosensor, and these upper 2 pins are from the LED. Back to the first connection we need to make, and that's for the 2 ground pins. The simple and easy way to connect those 2 is to just bend the lower left pin diagonally across so that it ends up lying down right next to the upper right pin. So the next thing we do is we take the upper right pin and we bend it outwards so that it lays down flat over the strip that it's on. Perfect. Now those two pins of course need to be soldered together, and then we can draw a cable off to ground from there. So now I'm ready to install the resistors. I'm going to start with the resistor for the LED, which is this 220 ohm resistor right here. And I know from the drawing that we made before that the upper left pin is the positive pin for the LED. And so now I just need to run this off to one of the empty rails that we have here on the side of the strip board. So now the LED is in position and I can solder it into place, and then at the end I'll just run a cable to 3 volts from this side here. Cool, so I can just snip off the ends of that resistor, and I can snip off the end of the LED 3 volt pin as well now, because I've just soldered that into place. Looking good. So now this pin down here, the lower right pin, is the analog pin for the sensor. So I need to, on the one hand, run a cable straight off from there to the analog pin, but then I also need to connect this 47K resistor over to the 3 volt signal. So I'll start with the resistor, and that goes there. Right, so we already have a 3 volt signal that we connected this resistor to, so I'm just simply going to connect this other resistor to that same rail over on that side. There you go, and so now that resistor is in position, and it's ready to be soldered into place. Cool, and with that I've also soldered the last pin of the CNY70, and so I can snip off the end of that and also clean off the ends of the resistor. Nice. Reorient the sensor, text is on this side, turn that towards myself so I still know where I'm at. Cool, so now all of the components are in place here on the strip board, and I just need to solder on some cables, put some female headers on there, and we should be good to go. So here's a scrap bit of cable left over from another project. Let's just clean that up and get that on there. So let's see how we connect this. I'm going to mark this cable here on 2 of the cables with red and black for 3 volts and ground. So that's this here, and then of course down at the other end I'll just quickly mark that as well. Then I will mark the other one with black for ground. I'll do that on the opposite side, just like that, and then over here. Let's start with the 3 volt connection. We need to connect that to the extra rail that we picked out. We ran the 2 resistors off to another rail, and so that's where the 3 volts come in, and that I can clearly see is this spot right here. I'm going to solder the 3 volt cable right into that. Okay, that was a little ugly, but it's gonna work just fine. Then we have the ground connection. So let me just get some solder on there. And then the cable. There. Excellent. So then all that's left is the signal pin. Totally lost track of how my sensor is turned now, so I need to just find the text. That was the dot. Here's the text. Turn it towards myself, and I'm reoriented according to our original drawing. So now I know that the signal pin is the lower right hand pin here, and so I'm just going to solder the signal cable onto that rail right there. Nice. Now all 3 cables are connected. Let's just see how that works. So of course now it's time to apply the foam sticky tape inside here and see if we can't hold this into place in some kind of useful way while still maintaining it adjustable. So let's just back up the camera a little bit so we can see what we're doing. Just cut these right down the middle, make 4 strips. Pretty nice. Cool, so let's just try to sneak this sensor in here and see if that makes any sense at all. Yes! Oh, that's gonna work just great, but one of my pieces of tape just came loose, so I'm gonna have to work on that a little bit. So that works really great. I'm able to just push on this thing to adjust the height and position of it, and so depending on the sensitivity that I get from the resistor that's on the photosensor, I can adjust accordingly. So then I almost forgot, I need to of course solder some female headers on here and on the other sensors that I use. So I need to select some of these, the ones that seem to be in best shape. And then I just need to maybe trim off the edges here a little bit so that I can fit them into the bamboo pieces. But I'll start with the female headers. Now all that's left to do before I plug these into the breakout board is to cut these other 3 sensors down to size and then use the foam sticky tape to stick them in here. Let's do it. Yeah, I might actually have cut that a little bit too small, but you know, nothing that a little extra sticky foam tape can't fix. Nice, no problem, that is not too small at all. Very cool. That's all 4 of them. So now the cable coming out here, the bottom is kind of a pain because it just keeps it tilted like this. So I'm just gonna try to awesome, that's all of them, complete with sensors and cables and all. So now before I put the membrane on there, I really want to test them, so I'm just going to quickly plug them into the TNC breakout board, then I'll bring them over to the computer, test to see if everything works, and then adjust the height of each one. I'll bring over a little bit of membrane here so that I can test the sensitivity and how high the sensor needs to be placed within the bamboo. Cool. Be right back. Okay, they all work perfectly, which is super sweet, and also I adjusted the height on each one so that I get similar resolutions on all of them. Good, now for the membranes. Getting these on here is actually quite easy. You need the full balloon just with the mouthpiece cut off, and then you can simply take the whole thing, stretch it out over the drum like so, getting all the way down under it to the other side. And so it's very easy to get into place in that way. Then we need to put the black balloon over top of that. Excellent. And then just to make sure that it stays in place, I'm going to take a little rubber band here and stretch it over that top bit like so. And then I can pull this back and expose the bottom section again like that. I'll just quickly do the rest of these and then we can get on to putting some code on this thing and making some noise. Sweet, that's the full drum set. Have a closer look at that. So I might glue these all to some kind of support at some point so that I can get a fixed position for each of them. But right now I don't know what that fixed position will be, so I'm just going to bring them over to the computer just the way they are now and then try to figure it out from there. So let's go. Okay. So you might notice that I tied some extra rubber bands around all 4 of these just so that I can pick them up and sort of handle them as a single unit, which is very practical. I can even hold them in one hand and play them with the other, which is super nice. So as usual, I've cheated a little bit and I made all the code for the drum set beforehand, because watching me code is slow and painful like a root canal. So I did manage to save a couple of files along the way, just so that you can follow along in the steps that I went through to make it work. So let's plug it in and get started. So here's the first file. This is the file that I wrote just a second ago as I was testing out the drums individually. Very simple. It just defines 4 analog pins, then it starts the serial, and then in this little for loop I read the 4 pins and print them directly to the serial. So let's try and upload that. Looks like that worked just great. Let's try and open the serial monitor. That looks very nice. We have 4 readings, all with similar values. So let's see how that maps onto the drums. Okay, that's the first sensor. That looks great. It bottoms out at around 55 or so. The second sensor also bottoms out around 55. This is the 4th sensor. And the 3rd sensor, and they all have roughly the same sort of range and similar resolutions, so that's super nice. So here's the second file. Not a whole lot of changes here. We're still reading the same 4 analog pins, but this time I added a couple of arrays, one to keep track of the readings and then one to keep track of the output values. Then I also registered in this array the maximum reading of each sensor, and then in this value here I have the common minimum value for all the sensors. Then I start the serial, and then in this for loop here I first read each of the sensors, and then I map them between 0 and 127, and then I limit them to that range of values, and then I simply print them to serial. So let's try and upload that. Okay, that seems to work great. Let's try and open the serial monitor. That looks very promising. So we have 4 0 readings, which means that the mapping is probably working fine. Let's try and check that out. That is perfect, from 0 to 127. Let's check this one. 0 to 127. That's super great. No glitches, no problems. All 4 sensors are mapping correctly, so the second file works. Let's check out the third file. So here's the third and final file. As you can see, there's a lot of extra stuff in here, so I do apologize for stuffing so much new stuff in one single file. But as I was writing this, I was just in such a beautiful flow state that I had a really hard time remembering to stop and save a fresh file along the way. So let me just try to explain a little bit what's going on here. I'm still defining the same 4 sensors, pins, the arrays to keep the values that I read from them, but now I also included, as always, an array to keep track of the previous reading so that I can see if there's any change. So then I introduce a few new values here that have to do with the velocity on each sensor. MIDI velocity is basically the measure of how hard you hit the sensor. So the harder you hit it, the more volume you want the synthesizer to give. And the softer you hit it, the softer the sound should be. So the way I do that is I use this value here to differentiate the first moment when I hit the sensor and the very first reading that I get from that, from all the subsequent readings that I might get while I hold the membrane down. And then I use the difference between the first and the second readings to know how fast my finger was moving at the moment of impact. I hope that makes sense. I'll explain in a little bit more detail in a second when we get down into the for loop here. But first we have some more arrays. First of all, there's the sensor velocity minimum. This is a hand-picked value that I picked out, and I use it to map those first 2 readings on each hit of each sensor to a useful velocity value. Then I have an array here called MIDI note, and these 4 numbers here are of course the MIDI notes that I want each sensor to output when I hit it. Then each drum is mapped out to a separate MIDI channel so that I can control the volume separately. And then I define a continuous controller for each drum. As you can see, in this case I'm using the same one for all of them. Then finally there's this velocity timer value here, which is populated during the void loop with millisecond values, so that I can measure the distance in time between the first sensor reading when I hit one of the drums and the next one, so that I can see if enough time has passed to then read the velocity value. Okay, so then of course we start the serial, blah blah blah, and then the interesting bit starts. First thing I do is just keep track of the previous value that was read before I read a new one. Then of course I read the sensor, and then I map that sensor to the MIDI values that we just had before. So that's all the same as before. We limit it within MIDI range. If the current sensor reading is not equal to the previous sensor reading, then we automatically send a continuous controller signal out to the MIDI channel that we're currently working on. So we're constantly setting the volume on each drum, which allows sort of like an aftertouch vibrato-like functionality that I will show you in a second. Then we get into more specific cases. If the previous sensor reading was 0, so if the drum was not being touched, and the new sensor reading is not 0, then we activate the corresponding slot in the preparing velocity array. So we turn that from 0 to 1. And then we set the velocity timer for that sensor, meaning that we store the current millisecond reading as the time that the sensor was activated. Then we have an else if conditional here, meaning that if this is not the case, then we check if this value here is already equal to 1, meaning that we are already preparing velocity. If that is the case, then we set this temporary current time value to the current milliseconds, and then we subtract the velocity timer value from before from this current time to see if the result is more than 1. That means that more than a millisecond has passed, and if that's the case, then we go into this whole section here. So just to recap, if the preparing velocity value is equal to 1, that means we're on the second reading of this hit on the drum. And if the time that has passed between the first and the second reading is higher than 1 millisecond, then it's time to calculate the velocity. So that's what happens here. First we read the sensor again and store the results into this temporary vel value. Then we map that value into a MIDI range using these sensor max and sensor velocity minimum values that I showed you before. And then we limit it within the MIDI range. Then we still have the serial outputs here just to troubleshoot the whole setup. And then of course we output this USB MIDI send node on with the velocity that we just calculated. Then we set this preparing velocity variable again back to 0, just so that we don't continuously output velocity values. And that's it. Pretty complex, but it does have to do rather a lot of stuff. So let's just try and upload that and see if it works. Looks like that worked great. Let's try and open the serial monitor. And we're not getting any output, and that's a good thing, because the only output that I am printing here is in the case that we output a velocity value. So that should only happen on a fresh hit on each drum. So let's see if we can make that happen. Okay, we got a 127 reading on sensor 0. So what if I hit it softer? Oh, we get a softer value. What if I hit it really softly? Ooh. So it's very sensitive. I might want to map that slightly differently. But for now it works just fine. There seems to be a slight delay on the serial output, and I'm not really sure what that's about, but for the MIDI output it works just fine, there's no problem there. So I'm going to just ignore that. Let's try the other sensors. That's sensor number 3, also a 127 value. Let's try a soft hit. Oh, that was too soft. 16. 61. Let's try this one. That's sensor number 1. That has the best sensitivity of all of them so far. This one, sensor number 2. That also works great. I really like that sensitivity. So I say that pretty much works exactly the way I want it to. I think it's time to open up Yoshimi and see if we can't use this thing to make some noise. So as usual, I'm running the Yoshimi synthesizer through Jack. That's my preferred setup. It's all open source and free, and it works just great. And Yoshimi has some quite nice drum kits, which is what I'm using right now. As you can see, I have the drum kit set up on the first 4 MIDI channels, and that is so that I can control the volume of each drum separately, but I'm running the same patch on each channel. So moment of truth, let's see if this whole thing works. I'm gonna start with this one out here. That's the snare drum. that has some very nice velocity sensitivity. Playing very softly. I'm not sure you can hear that in the camera. But then as I augment the velocity of my finger, we get a higher velocity value and a louder and different sound. Because these patches are kind of velocity sensitive, so I get a rounder and more dampened sound here, and then all of those high frequencies come in when I really hit it very hard. Also, the sound in itself is actually longer than what you're hearing now, but the only way that I can make that sound to the end is by holding the drum down after I play. That's because I'm constantly outputting a volume signal, and if I hit it and let go, then the volume immediately goes down to 0. So that means that I can hold it down and I get that aggressive sound, and it keeps going onto the natural end of that drum. This also means that I can actually control the volume during that time. So I can get this sort of vibrato effect. Check it out. So I'm able to vary the volume of that snare drum sound until it naturally ends and it's gone. Let's try that back here. That's the tom. Also very nice velocity control. That works great. And the vibrato control works great on this one as well. Let's try this one here. That's the cymbal. Also a very nice velocity sensitivity on that. And then back here we have the bass drum. I'm not sure how well that comes through on the camera, but that also has a very nice velocity sensitivity. Man, that is just too much fun. I think it's time to put these drums to good use, doing what they were actually made to do, which is to record the drum track for the Kontrol Freak theme song. So let's do it!